At the end of the last clip, I read this as dt, dt, d capital T, dt over dr, dt. It's over magnitude of dr, dt as written. But that could be taken as our definition of curvature. Another very common way to define curvature is in terms of this, and that's in many ways more direct. Now, we'll get to that in a second, but let's look at this expression. We know how to calculate the unit tangent vector if we have our r of t vector, so that we know how to calculate the derivative of our unit tangent vector. That's a little bit of a pain, but it's a straightforward calculation if we take care and use the laws of derivatives correctly. And dr dt is generally very straightforward if r is a decently behaved function, a function that we know how to differentiate. Then this is an easy calculation. Now, our definition of curvature, common definition, curvature, and that's often designated by the Greek letter, lowercase Greek letter kappa, and that is nothing but the limit that we get if we use this expression. As delta t goes to 0, delta t over delta s becomes dt ds. And curvature is a positive or non-negative quantity, so that the curvature is dt ds, the magnitude of dt ds. Now, since typically our curve is going to be given as, in terms of the position function r of t, we're going to use this form. We're going to take the derivative of r of t, divide by its magnitude to get the unit tangent, take the derivative of that, and divide that by the magnitude of our dr dt, which we found in the process of finding the unit tangent. And that's going to be how we get the curvature. Now, we can say formally that dt ds equals dt dt divided by ds dt. But of course, ds dt is nothing but dr dt, the magnitude of dr dt, since the change in position is just position changes at a rate that's equal to the magnitude of the rate at which the r vector changes, according to what we have here. So formally we can write this. Practically, if we understand this picture, we see that this definition of curvature leads us to this calculation strategy, which is going to be the strategy we often use in calculating curvature. Now, there are other ways to calculate curvature, and we're going to take a look at those.